Okay folks, welcome back. So just another quick video. This time what I'm going to do is demonstrate how to run a repeated samples, repeated measures t-test using SPSS. So I got this data frame open in front of me, an SPSS.sav file. It's example data, it's made up data, and it relates to, the idea is that we've got participant ID, so we've got 50 participants, I believe, yeah, 50 participants, and each participant's got a test score from test 1 and a test score from test 2. So what we're going to do is look to see if there's a difference between their test scores between the first and second test. So did their test scores improve from the first to the second test after they've maybe received more teaching, more training in whatever it was they were meant to be learning. So to run a repeated measures within samples t-test using SPSS, really straightforward. As ever, we click on the analyze button. We're going to compare means and proportions, and it's called, the actual option we want in SPSS, it's called a paired samples t-test, so it's just another name for it. And to set this up, it's really easy. We just select our two variables that we're comparing, and we need to move them over to this paired variables block. So we'll move test 1 score over and then test 2 score over. So if we wanted to do a number of different repeated measures t-tests, we could select more variables there and just compare them. But we're only comparing 2 in this case. We're comparing participants' score in test 1 and score in test 2 to see if there's a significant difference. So you'll notice here this little tick box, we've got estimates of effect size, so it'll give us Cohen's d again, so we can assess the practical significance of any results that we might find. And I'm going to just leave standard deviation of the difference selected. You'll remember from the lectures when we've learned about the t-test, the repeated measures t-test, the paired samples t-test, whatever you want to call it, that the calculations are based on different scores essentially. So I'm going to click OK, and that will give us the usual SPSS output window with a number of different tables. So first of all, we've got a table of descriptives, so it gives us the mean scores for each of our two groups. So the test 1 score, the mean is 41.36, test 2 score, the mean is 52.72, so higher scores for test 2. And if we look at the standard deviations as well, they're 11.32, 10.48, they're roughly about the same. So higher scores for test 2, but does that equate to a statistically significant difference? Were they did our participants get statistically significantly higher scores in the second test compared to the first test? So to answer that, what we want to do is look at our third table, our paired samples test table, and it gives us a t-value here. Before we look at that though, one thing that's worth mentioning is, when we did the independent samples t-test, it gave us Levene's test as well. So Levene's test was a test for homogeneity variance. So that is a test that's only relevant for independent groups designs. So when you've got different participants in the different groups. When you have a design where you've got multiple groups, like 3, 4 or more, there is a test that assesses differences, variability between the groups, which is commonly used, called Mortley's test of sphericity. But in this case, where we've only got 2 groups, we're comparing whether assessing variability around the group means and trying to establish whether the groups have come from the same population isn't really relevant in this case, because it's the same participants in each group. Before we look at the t-test as well, one other thing I will mention is we've got this. It gives us this paired samples correlation. Test 1 score is basically Pearson's R correlation of 0.955 and a significance value of p is less than 0.001. So we've got a statistically significant correlation between test 1 score and test 2 score, and that is a positive correlation, it's a positive value. So what that's telling us is, before we even look at the t-test, participants who scored higher on test 1 also scored higher on test 2. Or that was the general trend in the data. But what we want to know is there a significant difference between participants' test scores, between the groups, test 2 score mean and test 1 score mean? So let's look at our t-test value. So we've got here a t-value of, it's given us negative 23.729. We've got degrees of freedom of 49, and if we look at the two-sided, two-tiled significance, p is less than 0.001. Okay, so we've got a statistically significant t-test. The fact that it has a negative value in front of it, it doesn't really matter when you report a t-test. The only thing the test statistic t for a t-test, the only thing you're really interested in is the absolute value of that test statistic. So you could just report this as 23.729. The fact that it's negative is just a function of which group was subtracted from which other. So test one had the test one mean had the test two mean subtracted from it. So a smaller value had a larger value subtracted from it, and that's given us a negative result. So these are associative or commutative. Can never remember which way around it is. So we could have reversed that, and it subtracted test one from test two. What we would have found then is we'd have still got the same t-value. It would have been a positive number. So all you really need to remember is that whether it shows a negative or a positive value for the t-test, you can ignore the negative and just report the absolute value of the t-statistic. And as I said, we've got a significant t-value here. We've got a significant t-test. And to put that in context, if we look at our means, what that's telling us is participants' scores on test 2 were statistically significantly higher than their scores on test 1. So their performance improved in test 2 compared to test 1. Does that equate to practical significance? Well, to answer that, we can look at our measures of effect size, and we asked for some effect size. It's given us a couple: Cohen's d and Hedges correction. And Cohen's d is the one we'll look at. And if we look at the point estimate, on this occasion, it's also given us a negative 3.356. The fact that it's negative is just a function of the fact that the large group was subtracted from the smaller group, just as the t-value was calculated. So if we look at the absolute value of this point estimate, an effect size of Cohen's d of 3.356 would be a very huge measure of effect. So we have a statistically significant difference, but also a practically significant difference in terms of test score. So participants improved greatly on the second test compared to the first. Okay, so that's it. That's the repeated measures t-test. Nice and simple to run in SPSS. And I'm going to stop recording now. Thank you for listening and watching.